2016 question 10 part B. A particle moves in a straight line in such a way that its acceleration is always directed towards a fixed point O on the line and is proportional to its displacement from that point. The displacement of the particle from O at time t is x. The equation of motion is v times the v dx equals minus omega squared times x, where v is the velocity of the particle at time t and omega is a constant. The particle starts from rest at a point P, which is a distance a from O. Derive an expression for, first of all, v in terms of a, omega and x. So the equation of motion was v times the v dx equals minus omega squared times x. If we want to solve this differential equation, we're going to bring the dx across and multiply and then integrate both sides. Now, the particle starts from rest, so the initial velocity is 0, but the initial displacement was a away from O. We want to then try and find out what v is in terms of x. If you integrate the left hand side, this gives v squared over 2, and if you integrate the right hand side, you get minus omega squared on x squared over 2. If you put in x, first of all, you're going to get x squared over 2, and then if you put in a, that's going to give minus a squared over 2. On the left hand side, this will just give v squared over 2. Multiplying everything by 2 then, v squared equals minus omega squared on x squared minus a squared. And if we multiply in by the minus on the right hand side, v squared just equals omega squared on a squared minus x squared. So if we want to find out what v is, we're going to get the square root. Now the square root of omega squared is just omega, so we can take the omega out in front, and v then just equals omega times the square root of a squared minus x squared. Part 2 then, we want to find x in terms of a, omega and t. Now v is the same as dx dt, so dx dt equals omega times the square root of a squared minus x squared. And if we bring the dt across and multiply, and the square root of a squared minus x squared, we can bring that across and divide. Now if you integrate dx over the square root of a squared minus x squared, this is a standard integral, and this gives the inverse sine of x over a. On the right hand side, if you integrate omega times dt, this just gives omega, and then we've got t. And the limits, time goes from 0 to t, and again the displacement goes from a up to x. If you substitute in x, first of all, you get inverse sine of x. Then substituting in a, that's going to be minus inverse sine of a over a, which is just inverse sine of 1. And then on the right hand side, we're just going to get omega times t. Now inverse sine of 1 is pi over 2. And if you bring that across, it becomes a plus pi over 2. And we're trying to get x on its own. If we bring the inverse sine over, you get the sine of omega t plus pi over 2. And then x is being divided by a. If you bring the a over then, this means x is going to equal a sine omega t plus pi over 2.